Exercise 728 is just trying to get you to look at molecules and see possible SN1 and SN2 reactions. So they give you the structure for this strange molecule, and they want you to see where you could possibly do an SN2 reaction and where you could possibly do an SN1 reaction. So look for all the leaving groups. We know bromine's a good leaving group, chlorine, chlorine, and then this TOS, that's a tosylate. That's one of these awesome leaving groups here. So all of this, everything in this table is an excellent leaving group, and you can see why. Because if you have a negative charge there, the negative charge based on a lone pair, those are allylic to both of these pi bonds. And those are conjugated with this ring. So really, the negative charge is spread out through a whole huge area. So this molecule can handle having a negative charge there. It's spread out a lot through resonance. And so that's an awesome leaving group. It can take electrons and just leave the molecule. So those are all leaving groups. Notice that the others aren't. If you tried to make this molecule come off, you'd have a full negative charge on a small atom. And the same here, full negative charge on a small atom. So those wouldn't be able to stabilize the negative charge. They wouldn't be able to spread out. So here, on this molecule as drawn in this video, you would just look at each of those leaving groups and ask yourself, is the leaving group on a primary, secondary, or tertiary carbon? So this tosylate group is on a primary carbon. It's only bonded to one other carbon. And we saw in previous videos, in our discussion on understanding substitution reactions in that video, we saw that a leaving group on a primary carbon favors an SN2 reaction. So you can do an SN2 reaction there. Similarly, this is a primary carbon, so SN2, you can do that there. This other chlorine, that is on a tertiary carbon, 1, 2, 3. If you have a leaving group on a tertiary carbon, we've seen in previous videos, we've discussed that favors an SN1 reaction. Both in the previous video, the one right before this, 727, and also in the video on understanding substitution reactions. So if you want the reasoning behind why a leaving group on a primary carbon favors SN2 or a leaving group on a tertiary carbon favors SN1, I encourage you to go to those videos. This bromine is a leaving group. It's on a tertiary carbon, 1, 2, 3. Carbon is bonded to 3 other carbons, so it's a tertiary carbon, and so that would favor SN1. And so that's all these two parts are asking you for. They're asking you to identify where you could do an SN2 or an SN1 reaction in this molecule, and so that's what we've done. You identify the leaving groups, look at what type of carbon they're on,